In this video, we're going to talk about the displacement field and Gauss's law. Well, what is the displacement field? Well, imagine you have a stationary atom. If we apply an external electric field to the atom, the free electrons align themselves with the field and create an electric dipole moment, which basically means that we get two distinct polarities of charge on the atom. Now let's get to some math. The displacement field is a vector quantity and it is defined as epsilon naught E plus vector P. Epsilon naught is the electric permittivity of free space, which is a measure of how well an electric field forms in free space. Vector P is the dipole moment density, or how many dipoles there are per unit volume. This definition takes into account how the electric field forms in free space, plus how the free charges in the atoms affect the electric field by creating dipoles. In certain materials, the dipole moment density is proportional to epsilon naught E. The constant of proportionality, chi sub E, is called the electric susceptibility, which is a measure of how susceptible a material is to an electric field. Plugging this into the equation for D, we get the following. We're going to define 1 plus chi sub E to be equal to epsilon sub R, which is called the relative permittivity. Plugging this into the equation for D again, we get this. We are going to make one last substitution. We will define epsilon naught epsilon E to be equal to epsilon. Applying this substitution, we get our final form for the displacement field, where epsilon is the permittivity. Now we can move on to Gauss's law. Gauss's law states that the total electric flux through any closed surface is equal to the total charge enclosed by that surface. But what is flux? As an example, imagine you have a solar cell and the sun is shining on it. The amount of sunlight it receives from the sun is the flux from the sun. If you had a bigger solar cell, you would receive more flux since the surface is larger. So simply put, flux is a measure of how much a field, or in this case sunlight, passes through a surface. Now let's write down Gauss's law. Phi sub E is the total electric flux, and QENC is the total charge enclosed by that surface. The total flux is equal to the closed surface integral of the displacement field through the surface. The circle through the integral signs represents that it's closed. To explain this equation, let's look at the following image. The square represents some differential amount of surface ds. The d vector, shown in orange, always has a tangent and normal component. The tangent vector will always be parallel to the surface and technically never goes through the surface. Therefore, it contributes no flux. The only component that contributes flux and passes through the surface is the normal or horizontal component, which is equal to d ds cosine theta, or simply d dot ds. The total charge is equal to the volume charge density integrated over the volume of the object. Plugging both of these relations into Gauss's law, we get this. We can use the divergence theorem on the left-hand side to write the surface integral as a volume integral. Plugging this back in, we get this. Since the two integrals are integrating over the same volume, the integrands of both sides must be equal. This leads to the final form of Gauss's law. We now have both forms of Gauss's law. The top, which is the differential form, and the bottom, which is the integral form. Both forms are completely equivalent. Gauss's law is one of Maxwell's 4 equations. Thanks for watching. Make sure to rate, comment, and subscribe.